Welcome to the DIY Honda Garage channel. The DTC P0341 indicates a problem related to the Camshaft Position (CMP) sensor and the Crankshaft Position (CKP) sensor not being in sync with each other. These sensors play crucial roles in determining the engine's timing and synchronization. The CMP sensor monitors the position of the camshaft, while the CKP sensor monitors the crankshaft position. Both sensors provide necessary data to the Powertrain Control Module, PCM, for optimal engine performance. If they are out of phase, it can lead to misfires, poor engine performance, and even hard starting issues. Understanding this DTC involves recognizing both sensors' roles, their locations, typically near their respective shafts, and the implications of a timing error, which could stem from a variety of causes. The following slides will guide you through an effective troubleshooting process. The error code P0341 specifically flags an issue where the Camshaft Position (CMP) sensor and Crankshaft Position (CKP) sensor detect an incorrect phase between themselves. The CMP sensor's role is to track the camshaft's position, which is essential for the engine's valve timing. The CKP sensor, on the other hand, monitors the crankshaft's location, providing data critical for ignition and injection timing. Both sensors are typically located near their respective shafts. The CMP sensor is often found near the camshaft, and the CKP sensor near the crankshaft. This synchronization is vital for the Powertrain Control Module, PCM, to operate the engine efficiently. If there's a timing mismatch detected between these two sensors, it can disrupt the engine's performance, leading to a multitude of issues that might include stalling or reduced power output. When diagnosing DTC P0341, several potential causes should be considered. Incorrect camshaft timing is the first aspect to examine. If the timing is misaligned, it can lead to improper phase detection. This can arise from wear and tear or improper installation. A second plausible cause is the timing belt, which may have become damaged or frayed over time. A faulty timing belt can cause the camshaft to fall out of sync with the crankshaft, leading to performance issues. Another cause is poor electrical connections, loose or corroded terminals at either the CMP or CKP sensors, or even related connections to the Powertrain Control Module, PCM, can interrupt the flow of critical information needed for the sensors to operate correctly. Addressing these potential causes is essential for troubleshooting the P0341 DTC efficiently. The symptoms associated with DTC P0341 can significantly impair the vehicle's operation. One of the primary indicators is an engine misfire, which occurs when the cylinders fail to ignite properly due to incorrect timing. This can lead to rough idling or stalling. Drivers may also experience general poor engine performance, such as hesitation during acceleration or reduced power, making the vehicle hard to drive efficiently. Additionally, difficulty starting the engine may arise, as incorrect timing can interfere with the combustion process. Understanding and recognizing these symptoms will help in pinpointing the issue that DTC P0341 represents. The first troubleshooting step for diagnosing DTC P0341 involves checking the camshaft timing. This process is imperative because the camshaft timing affects how synchronized the CMP and CKP sensors are. To conduct this check, you will need to access the engine timing marks and confirm they are aligned correctly. If the camshaft timing is confirmed to be accurate, you will proceed to the next step. However, if the timing is found to be off, the camshaft timing will need to be reset. Ensuring proper timing is essential, as any misalignment can lead to significant performance issues and further complications in engine operation. After confirming the camshaft timing, the next step is to check the timing belt for damage. The timing belt plays a crucial role in maintaining the synchronization between the camshaft and crankshaft. Any signs of wear, fraying, or damage can lead to misalignment, which would trigger DTC P0341. If you find that the timing belt is indeed damaged, it will need to be replaced, along with the timing belt auto tensioner to ensure proper function. Should the timing belt be in good condition, the technician can then move on to the next troubleshooting steps. It is vital to address timing belt issues promptly to avoid higher repair costs or engine damage. In the third troubleshooting step, you'll conduct a powertrain generation management system check. Begin by turning the vehicle ignition to the on position without starting the engine. This allows the vehicle's systems to initialize. Next, reset the powertrain control module, PCM, using the Honda Diagnostic System, HDS. Resetting the PCM is crucial to clear any previous fault codes and ensure that you're starting with a clean slate for diagnostics. Following the reset, perform a crankshaft pattern clear procedure if necessary. This phase allows the PCM to realign with the CKP sensor's readings and ensure that it can accurately monitor the system's performance. This process is an integral part of troubleshooting DTC P0341, as it resets learning parameters that may have been affected by the detected error. After resetting the PCM, you will perform the Crankshaft Position, CKP, pattern clear procedure as the fourth step in troubleshooting DTC P0341. This crucial step works to clear any lingering patterns or faults stored in the PCM from the CKP sensor. By doing this, the PCM is able to reset and prepare itself for a new learning phase. This step is quintessential to ensure that it can accurately gather information from the CKP sensor without interference from old data. Following the CKP pattern clear, be ready to perform the idle learn procedure, which allows the PCM to adapt to the vehicle's idle settings. This ensures optimal engine performance and adjustments based on real-time data from both the CKP and CMP sensors. In the fifth step, you will execute the Crankshaft Position CKP pattern learn procedure. This step is vital as it helps the powertrain control module, PCM, to re-establish its understanding of the CKP sensor's position and data following the previous resets. The CKP pattern learn procedure involves allowing the vehicle to reach specific operating conditions during which the PCM can learn the new crankshaft position signal. This enables better synchronization between the CMP and CKP sensors. A successful CKP pattern learn can help prevent future occurrences of DTC P0341. After performing this step, ensure that the engine is idling smoothly to confirm that the synchronization achieved. Following the CKP pattern learn procedure, you will start the engine and allow it to idle as the sixth troubleshooting step. Monitoring the idle conditions will provide valuable insights about the performance of both the CMP and CKP sensors after the various diagnostics performed. During idling, it is important to observe any irregularities, such as oscillations in RPM or unusual sounds. A smooth, stable idle suggests that the sensors are functioning correctly and are properly synchronized. However, if irregularities are observed during this phase, it may indicate that further investigation into the timing mechanisms or sensor connections is required. This idle check serves as a real-world assessment of the previous troubleshooting steps taken regarding DTC P0341. In the seventh and final troubleshooting step for DTC P0341, you'll need to check for any confirmed or pending Diagnostic Trouble Codes, DTCs, using the Honda Diagnostic System, HDS. This procedure helps determine whether the corrective actions you've taken have resolved the initial issue. If DTC P0341 is indicated again, this suggests ongoing problems with either sensor, their wiring, or connections. It's crucial to check for poor connections or loose terminals at the CMP sensor, CKP sensor, and the Powertrain Control Module, PCM, to ensure data transmission is occurring without interruptions. If no DTCs are present, it could indicate that the fault was intermittent and has resolved itself. Nonetheless, it is advisable to recreate the conditions that led to the DTC initially, based on any onboard snapshot data, if recorded, to fully ascertain the successful completion of the troubleshooting process. Final repair verification after addressing DTC P0341 is key to ensuring that all sensor and timing components are functioning optimally. Begin by monitoring system performance through a test drive. This allows you to evaluate how the engine performs under different loads and speeds, ensuring that the solutions implemented are effective. While driving, pay close attention to any warning lights, particularly those related to the engine or performance. You should also observe how the engine idles at stoplights or during idle conditions. A smooth operation without engine misfires or unusual sounds indicates successful troubleshooting. This step is essential for confirming that all systems related to the CMP and CKP sensors are working harmoniously, and any previous issues have been rectified. To prevent future occurrences of DTC P0341, incorporating regular preventive maintenance practices is essential. Start by scheduling consistent timing belt inspections, as a faulty or worn belt can lead to synchronization issues between the CMP and CKP sensors. Additionally, it is advisable to inspect electrical connections to these sensors frequently to ensure there is no corrosion or loose terminals that could disrupt data flow. Keeping an eye on the performance of these sensors and the timing system will help in catching any potential issues early, before they lead to significant problems. A proactive maintenance strategy will help to ensure that the engine remains in optimal condition, reducing the likelihood of activating DTC P0341 again. In conclusion, understanding DTC P0341 requires a thorough knowledge of the roles and functions of the CMP and CKP sensors, as well as recognizing the importance of their synchronization. Properly diagnosing this issue involves a systematic approach, starting from checking the camshaft timing to ensuring the proper performance of the timing belt. Throughout the diagnostic process, monitoring the vehicle for symptoms, checking DTCs, and addressing possible causes is crucial. Additionally, final verification of repairs ensures that the issues have been resolved effectively. Implementing preventive maintenance practices consistently will help minimize the risk of encountering this DTC in the future. Following these guidelines will ensure your Honda Pilot functions smoothly and efficiently. Please like and subscribe to the channel. See you next time.